I'm going to work a couple of these practice problems that had fractions in them. So number 6, I want to eliminate my fraction by multiplying 3 by 15, and that's going to give me 5x minus 15 is equal to 3y. Now, since I'm solving for x, the most loosely attached is the 15. So I'm going to add the 15 to both sides, and I'm going to get 5x is equal to 3y plus 15, and then I'll end up by dividing by 5 and get that x is equal to 3y plus 15 divided by 5. Example 7 or problem 7, again, I want to get rid of my 1/3 first. So I'm going to multiply 3 by 3 and get 3b is equal to pi r squared. And I'm solving it of h. And then I'm solving it for the h. So I'm going to need to divide by the pi r squared on both sides. And this is going to be my answer is equal to h. So 3r. So 3, is it an r? 3b divided by pi r squared is equal to h. Then this next example, you have a couple different ways you could do it. We could do 2x plus 2a is equal to 4b because we needed to free up and get the a out of the parentheses. Then we would subtract the 2x. So 2a is equal to 4b, subtract 2x. So I've got to subtract the whole clump there. And then end up dividing by 2 so that I get a is equal to 4b minus 2x divided by 2. We have discussed earlier how there was an option here on problems like this, and I could divide both sides by 2 to begin with and get x plus a is equal to 4 over 2 is 2b, and then end up subtracting the x, so I get a is equal to 2b subtract x. Now remember that when we have this, we learned earlier that this is simplified with the distributive property to look this way, and so I end up here with 2b minus x, which is the same thing, is equal to a. All right, so examples here. Example 2, we have a rectangle. So I have a rectangle, and the length of the rectangle is twice the width. So if we let x be the width, then the length is 2x. The perimeter is 84, so we have 2 width plus 2 times 2x, which is the length, and it's going to be equal to 84. So that's one of the equations that we could do. You could have also added x plus 2x plus x plus 2x. So simplifying it, I get 4x is equal to 84, 6x is equal to 84, and then x is equal to 84 divided by 6, which is going to be 6. So we'll do that once, and then 24 4 times. So x is equal to 14. So my dimensions then, the width here is going to be equal to 14 centimeters, and the length is going to be 2 times that, so it's going to be 28 centimeters. So those are my dimensions. This is length, this is width, and this is length right there. Example 3, one angle in a triangle is 25 degrees more than twice the smallest one. I think I'll go ahead and just label these first, second, and third angle in those triangles. One angle in a triangle is 25 more than twice the smallest. So we'll let this be the smallest one here and call it x. So another one is 25 more than twice that. So 25 plus 2x. And another angle is 5 more than 3 times the smallest angle. So 5 more than 3x. So here's my 3 angle degree representations. So I want to find out what those are equal to. We know they all add up to 180 in a triangle. So x plus 2x plus 25 plus 3x plus 5 is equal to 180. So that's going to be 3. That's 6x plus 30 is 180, 6x is equal to 150, and x is equal to 150 divided by 6, which is going to be, that goes into 25 times. So that tells me then that the first angle, which is x, is going to be 25 degrees. The second one is going to be 2 times 25, which is 50 plus 25, so that's 75 degrees. And the third one is going to be 3 times 25, so 75 plus 5, which is 80. And that should add up to 180 degrees. Example 6, I have a number is 60 greater than 3 times its opposite. So we'll let x be equal to the number. And the opposite of that would be a negative x, so this is equal to the opposite. So a number, so that's x, is 60 greater than, so 60 plus 3 times its opposite. So 3 times a negative x, so that really looks better as a negative 3x plus 60 is equal to x. So to solve that, I'm going to add the 3x to both sides, and as a result get 4x is equal to 60. Divide by 4, so I get 60 divided by 4, which is going to be 15. So the number is 15. B says, this is, I guess, the next one. It's like we did the A, and I'm going to do the B. So 4 consecutive odd integers have a sum of 56. So I've got a first, a second, a third, a fourth. And the first one's x, and since it's odd, the next one's going to be x plus 2, x plus 4, and x plus 6. They have a sum of 56, so I'm going to add them all up. So x plus 2 plus x plus 4 plus x plus 6 is equal to 56. And I don't need the parentheses really, so I'm going to add up my x's, so it gives me 4 x's, and then 2 and 4 is 6, plus 6 is 12, is 56. So to solve it, I'm going to subtract the 12 from both sides and get 4x is equal to 44, and divide by 4 and get 44 divided by 4, which is 11. So my first number, x, is 11, then 11 plus 2 is 13, 11 plus 4 is 15, and 11 plus 6 is 17. And those are going to be my answers there. C, we have 2 consecutive odd integers again. So I have a first, which is going to be x, and the second, because they're odd, will be x plus 2. Okay, so this top one is the smaller one, and so we want to do twice the smaller, so twice the smaller, and the smaller one's x. Of 2 consecutive odd integers is, so that's equals, 7 more than, so 7 plus the larger, which is x plus 2. So to solve that, I'll go ahead and I will combine this and get x plus 9 is equal to 2x. Then I'll subtract my x from both sides and get that x is equal to 9. So my two numbers are going to be 9 and 9 plus 2, which is 11. So twice the smaller, that's going to be 18, is 7 more than the larger. So you can see that that's 7 more than 11. All right, so that is it for this video. Now, it may take me a minute to figure out how to make this turn off, but there's your practice problems that you can go by. So now you need to do that work.